This unit is called non-linear equations. So if linear equations are lines, what do you think non-linear equations are going to be? Circles, exponential functions, anything that's not a line, right? Okay, the first thing, the parabolas. The first thing we're going to do is go over our basic exponent properties that you learned in Algebra 1, possibly pre-algebra. Okay, the definition of a power. Okay, a power is a number with an exponent. Okay, where we have a base, in this case, our base is 2, and 5 happens to be our exponent. All right, looking back to our Algebra 1 class and possibly pre-algebra, these are the basic exponent properties, right? The first one is what's called the product of powers property. And notice that my bases are the same. So when I'm multiplying two powers where the bases are the same, what do I do with the exponents? Good. So if I have 2 to the 5th times 2 to the 6th, what do I get? 2 to the 11th. Good. Second property is called power to the power. Now, in this situation, I have a power raised to another power. Guys, quiet down. Again, every day, I gotta say this. Quiet down, quiet down, quiet down. Well, it's every day that I gotta do it. I'm gonna start sticking you guys in my sophomore class, because maybe that's where you belong. All right. When I have a power raised to a power, I have to multiply, bless you, my exponents. So if I have 2 to the 5th raised to the 6th, that's 2 to the 5 times 6, or 2 to the 30th. Now, I can't tell you how many times students are going to get confused. In fact, there's going to be half the class that's going to get confused in about 20 minutes here when you start doing your practice work. That you don't know when you're going to add the exponents or multiply the exponents. The easiest thing I can tell you to remember when to add them and when to multiply them is, do you see the parentheses here? When you see parentheses and you have a number outside of the parentheses, what do? You distribute, right? When you distribute, you multiply. When you distribute, you multiply. So that's about the only thing I can tell you that's going to help you. Is it the distributive property? No, but it's kind of like it. All right. The next one's the power of product property. Now, I know it looks the same as the one we just did, but it's not. Okay, notice I've got two different bases here. I've got an A base and a B base raised to the power of m. I still have to multiply that power to every exponent. Now, if there's not an exponent there, what is it? Yeah, the number 1. Okay? If I have a 3 there, if I have a 3x, the exponents are 1. I just made it up. Okay? I just made it up. Actually, it's right there. Okay, so it's 3 to the first, x to the first, and then I'm going to have to multiply each exponent. Okay, so it's going to be 3 to the 1 times 3, which is 3, x to the 1 times 3, which is 3. Now, you can multiply the 3 out. 3 times 3 times 3 to get 27. I don't care. You want to put 27 there? Fine. If you want to leave it 3 to the third, fine. I'm not testing you on whether you can multiply 3 times. I am testing you whether you know the property or not. Yes, if you multiply that. Okay, now, negative exponents. Do you remember negative exponents? Can you ever leave your answer with a negative exponent? No. What do you do to get rid of negative exponents? You flip it. Okay? It's not division. You have to think of this as over 1, just like any whole number. And what you have to do is you have to flip this fraction. Put the 1 on top and a to the positive m on the bottom. That's how you make negative exponents positive. Kayla. For instance, if I have 5 to the negative 1, actually 5 to the negative 1 over 1, flip it, but 1 over 5 to the first or just 5. I don't care if you put the 1 there or not. What about 1 over 6 to the negative 1? Yeah, 6 to the 1 or just 6 over 1 or just 6. This comes up over and over and over again, this negative exponent thing. Here's one that I think every student here, I co-teach with Mrs. Abruzzo, and there's about 65 students that just took a quiz on exponents. I think maybe 5 of them got this right. Anything raised to the 0 power is what? 1. 5 out of 60 students got that right. Anything raised to the 0 power is 1. Okay. Quotient of powers. What's a quotient? That's right, division. Okay, quotient means division. Notice I have to have the same base to do this, just like when I'm multiplying and adding the exponents. If I have the same base in a fraction, if multiplying and adding, what do you think I'm going to do when I'm dividing? Wonderful. So here I have 2 to the 8 minus 5 gives me 2 to the third. Again, if you want to multiply it out to 8, I'm okay with that. What about the next one? I have 3 to the fourth divided by 3 to the seventh. What does that give me? That's right, 3 to the negative 3. Okay, 4 minus 7 is negative 3. Then you can't leave negatives in my answer, so this equals 1 over 3 to the third. And if you want to multiply it out to 27, I don't care. Huh? Power of a quotient property. Now this is when I have different bases. Again, any number really is a power because it's always raised to the first power, right? No, I just ran out of conditioner. I did. I ran out of conditioners. That's all. I don't know what it is. And my softener's out of salt, so I don't have any soft water. Yeah, I know. Okay. I have parentheses. I have a number outside of parentheses, so I'm going to multiply each and every exponent. Okay? Even in the denominator. So if I have 2/3 raised to the fourth, this becomes, I have to multiply each exponent, bless you, 2 to the fourth over 3 to the fourth. And if you want to multiply it out, what is that, 16 over 81? Questions, comments, concerns? I highly suggest you do not lose these properties. Do not lose your packets. Let's do some example problems. Ew. All right, first one. I have a quotient here, different bases. So I'm going to have to take this exponent, multiply it to each one of the exponents. So I get r to the, I get r to the second over s to the negative 10. But I'm not done because can't leave negative exponents in my answer. So while I can't, because I still have that r to the second there, the r to the second stays in the numerator. I have to bring this s to the negative 10. Okay, remember now? Is it coming back to you? I'm sorry, my s's look like 5. Deal with it. What? Work on what? No, I'm 53 years old. I'm not going to change now. You're going to have to. You're going to have to deal with it as a 16-year-old student. What? All right. Let's do this one. Okay, I've got y first, correct? I have parentheses around this group. So I have powers raised to the power. So I have to multiply my exponent. So I have y, let me rewrite this. I have y to the first, z to the negative 2, x to 2 times 3 is 6, y to the first, or 1 times 3 is 3, z to the first. Yes, luckily you're taking good note and paying attention. Okay. See, x to 6. Here's my x's. So I have x to 6. My y's, let's see, I've got y to the first, y to the third. Okay, same base. I'm going to add the exponents. So I get y to the 1 plus 3, or 4. Z to the negative 2, z to the first, negative 2 plus 1, negative 1. Am I done? No, because I have negative exponents. Okay, x to the 6th stays where it's at. Y to the 4th stays where it's at. Now remember, this is all over 1. So I got to put that z to the first down in the bottom. There's my answer. These things, while they're easy, it's also easy to make a mistake. You've got to be very, very detailed. Okay, let's do the next one. Negative 4 outside the parentheses, which means I'm going to have to multiply to each one of my exponents. So I get 3 to the 1 times negative 4, which is negative 4. X to the 3 times negative 4 is x to the negative 12. Y to the negative 2 times negative 4 is y to the 8th. Again, I've got negative exponents. Put it over 1. 3 to the negative 4, I need to put down here. Make it positive. X to the negative 12, x goes down here, 12. Y to the 8th stays up there. There's my answer. Every day. Every single day I use this. You know what I do? When I wake up in the morning, I say, hey, honey, what's y to the negative 8 as a fraction? Then she answers me. No, she hates math. She works for the Veterans Administration. Let's do some subtractions. Okay, now, be careful here. This is one of those problems, I guarantee you, that's on the quiz. And again, I think maybe out of the 65 students, 10 of them got this one right. Okay. This two is outside the parentheses. It only is in the numerator. Okay. What happened was, on the quiz, the students multiplied it to the bottom ones too. The bottom one is not in parentheses. Be careful. So I get x to the 1 times 2 is x squared. Y to the 2 times 2 is y to the 4th. X to the 3rd, I'm not multiplying this. These are not in parentheses. Y to the negative 1. Now, there's a couple of different ways you can do these. Okay? It so happened that in Miss Abruzzo's room, she taught it one way, I taught it another, and a lot of students got confused. I just look at this and I say, okay, I've got fractions. I'm gonna follow, this is division. I'm gonna follow the quotient of powers property. That's the way I teach it. Hey, here's my x's. If I look at the quotient of powers property, when I have the same base, I subtract the exponents. So x to the 2 minus 3 is x to the negative 1. Y to the 4 minus a negative 1. Okay, I have a double negative. 4 minus 1, I'm actually adding them. So I get y to the 5th. I have a negative exponent. So I'm going to, and in the back of my mind, I've got this over 1. So I got to put it down in my denominator, and my y to the fifth stays in the numerator. Okay? Now, got it? Now, there is another way of doing these. You could, everything that's negative, yeah, you can make positive before you start subtracting. So here's x to the fourth. I could bring this x to the negative 3 up here, x to the 3, y to the third, and actually, I have y to the 0, that's just 1. Now you just add the 3 and the 4, yeah. So I get x to the 7th, y to the 3rd. Now, it doesn't matter how you do this. Okay? To me, it doesn't matter either. I happen to know the properties really well because every morning I ask my wife what's y to the negative 8. So it doesn't bother me to subtract the exponents. If you want to group them together, make them positive, and then deal with it that way, by all means do it. One more thing I want to do before I let you off. The next problem. Notice we got something new here, right? We have this 12 divided by 8. Just think of that as a coefficient. 12 divided by 8, don't forget about them. Don't just transfer them over. A lot of times they're going to divide out to a whole number. If they don't, make it the fraction. What is 12/8? Simplified. 3/2. Okay. What's x to the negative 5 minus 6? Yeah, that becomes x to the negative 11. Where's that going to go? Bottom, x, and I'm going to make the exponent positive. You're confused, aren't you? Because negative 5 minus 6, negative 5 minus 6 is negative 11. Got it? What about the y's? Y to the 7 minus 4 gives me, and where's that going to go? Up top. Want to do another one of those? Okay. So I think in your package here, you have a practice sheet. Yep, a lot of work. Why don't we do this? Why don't you go ahead and do this sheet? It can take you 5 minutes, 10 minutes tops. And then we'll do some harder problems tomorrow with this. Sound good? Practice this today. You should get this done today. And then I'll give you the practice worksheet tomorrow with some harder problems.